We know that acid-base chemistry is all about the transfer of a proton, or H+, from an acid to a base. So a Bronsted-Lowry base is the chemical that accepts the proton from the acid, or the H+. So on the slide here, we see an example of an acid-base reaction. And what's happening here is a base is actually dissolving in water. So when acids and bases dissolve in water, they actually react with water. So ammonia is a base and it accepts a proton from water. Water is happy to donate a proton to a base, and when it donates a proton, it gives up a hydrogen with a positive charge, so that hydrogen has no electrons. The electrons stay behind and stay on the oxygen, and once water loses a proton, it always forms OH-, which is known as hydroxide. So on the left-hand side, we see ammonia, which has lone pair on that nitrogen. That lone pair allows it to accept a proton from water. And after ammonia accepts that proton, this lone pair is used for a bond to that new hydrogen, and it forms this polyatomic ion known as ammonium, and water then becomes hydroxide. So just to sum up, when we dissolve acids and bases in water, if an acid is dissolved in water, water acts as a base and accepts a proton from that acid to form hydronium. And if a base is dissolved in water, water acts as an acid, donates an H+, and forms hydroxide. So Bronsted-Lowry acids always have a hydrogen that can be donated as an H+. Not every hydrogen atom in a molecule is acidic. A hydrogen has to be attached or bonded to an electronegative atom for it to be acidic, and usually that electronegative atom is an oxygen. Bronsted-Lowry bases have to have a lone pair to accept a proton, and typically these lone pairs are on oxygen or nitrogen atoms. And then finally, water can act as an acid where it donates a proton. This happens when a base is dissolved in water, or water can act as a base and accept a proton, and this happens when an acid is dissolved. So when water acts as an acid, it forms hydroxide, and when water acts as a base, it forms hydronium.